Meeting. Okay, Alan? Here we go. Welcome to the evening of Python coding. This is a meetup that explores new tools and Python libraries. Today, we are taking something very, very interesting. Um, the CEO of this company, I know him from several years ago. He just contacted me on a survey. And then we continued talking about it. And then they came up with Git hits, and I was amazed by some of the things I saw. I cannot go to too much details because Nathan will go and explain many of those details himself. And Nathan, you're the product manager of the company, or CTO, or what's the definition?
Yeah, so co-founder and chief product officer.
Okay, so Nathan will take it away. He can explain much better than me, but I will ask all sorts of questions of things that I've discovered. Git hits is really, really interesting from many perspectives. I expect a lot from them. Nathan, it's yours.
Thank you very much, Jacob. Really appreciate it. Hi, all. Great to meet you. I'm Nathan. I'm one of the people building Git hits. And what Git hits is we are a code context layer for your coding agents. So basically, coding agents have gone very good at working with the code bases they can see. However, when it comes to modern and enterprise software, our software stacks are very small. Like, our custom code is a very small percentage of the code relative to the open source code that our products are built on, the third-party SDKs, the integration, and that's a blind spot for models at the moment. So what Git hits is we're building an index of the entirety of open source code, an index that's version aware, and an index in which its dependencies are fully interconnected, so that before an agent ever gets started on a coding task, it can use Git hits, and we can give it everything it needs to know about the code it's using. So potentially, like, what about the license? Are you using this correctly in terms of the license? What about if there's vulnerabilities in this package? So we can scan for that. But then when it comes to the actual execution, we have a code intelligence and search layer on top of our index. So we can give your agent the exact code it's going to be working with before it ever starts writing a line of code. And so what we see from this is a lot of times the agents can, using Git hits, solve problems on their own that traditionally they couldn't solve because they have a knowledge gap. A lot of these models are trained on information 2 years ago. And so then they resort to web search, which web search is not very great when we're implementing code. It needs to be specific. So we see it completing tasks that it generally can't. It's a much better implementation because the agent is implementing the code in which the way it was written. And then thirdly, on long-running tasks, one of the most significant benefits we get is token reduction. So what we see is when you're having your agents build these bigger features or products, they have a lot of knowledge gaps. So without Git hits, they resort to doing a ton of web searches, burning a bunch of tokens on bad information, whereas we give your agents the context up front. So what I'm going to demo today is I'm just going to show you how I use Git hits with my coding agents. And I built a demo specifically using Monty from Pydantic. So I'll jump to that to give you a quick overview of what it is. So Monty is a minimal, secure Python interpreter written in Rust. So basically, if I were to give up a quick summary of what this library is useful for, it's LLMs and agents are very useful. And they have enabled us to build a lot of workflows that traditionally never would have been possible. However, agents will also do a lot of things which are extremely dangerous, and we do not want them to do. And they will constantly reach beyond the boundaries that they're supposed to. And so what Monty is it's an interpreter where you define the rules of what can be run. So you can define, it runs on your machine. It's a sandbox. So this demo I'm showing you, it's running entirely on my machine. But when the agent tries to execute any code using Monty, it has to follow the rules of, is it using the file system that we gave it permission to? Is it using the environment variables we gave it permission to? We can even control web search, the web traffic for it. And additionally, The way that this interpreter is built is you can actually take snapshots and resume. So you can imagine, say, your agent is having a long conversation with someone and there's a network error or something cancels it. What this library allows you to do is you can take a snapshot of that sandbox environment so that the user can resume it. So I'll jump into, the demo real fast. And so first, I'm going to be using get hits. The way that you can sign up is really...
Before you run away, the open code written, explain to people what they're seeing with the open code, because many don't know about this tool.
Yes, absolutely. So the tool I'm showing you right now is called Superset, and Superset is also an open source project. Let me throw that up here. This is a really great company as well. And basically what it is an agent orchestrator. So what it lets you do is you're familiar with Claude Code or Codex or Gemini, open code. So basically this tool creates work trees so you can have your agents working on an isolated branch and file system of your project. And then it allows you to run as many agents as you want against that branch. So it's basically a way that you can have a lot of agents running safely against a targeted branch. And I like to, open code is an open source alternative to Claude Code or Codex. And I like open code for a handful of reasons. One, it's open source. Two, it's adapted to work with pretty much any model you could imagine. So if I just hit the models command here, you can see I have OpenAI models, I have Anthropic models, we have open source models, Copilot, Grok. So it pretty much, Olama, you can run it locally. So what's amazing about this is, as I'm sure a lot of folks here have experienced, is there's been a lot of instability with different models and different model providers at the moment. So it's really important that we're not blocked by just a single model misbehaving. So I really like open code because I can run hundreds of different models in it. So I'll be showing you the demo through open code today. So the way that you get signed up for Get Hits is super simple. We're currently in beta right now, so we're completely free to use. And you just run the command npx get hits at latest init. And what that command is going to do is it will let you create your account. So if you don't have an account, you can create it from there. It's super easy, couple clicks. And then this command also configures your agents to use get hits. So right now, if you've worked with any MCP servers, it's a pretty manual process. You have to modify config files. You don't have to do any of that with this. You just run the command. You say which agents you want it to set up, and it'll set those agents up for you. So for the demo, I split it into 3 different components to show like 3 different levels of functionality for how we can use Monty. So the first step is just an agent running, giving a command to Monty and us letting it execute the Python in a sandbox. The next level is a step up from that, where we start to put rules in place of you're allowed to make this network call, but not other network calls. And then the third step is putting those 2 previous pieces together and then showing how we can crash a session and resume it. So I'm pretty much just built a demo highlighting the features of this library, but I want to show you how I build this with Get Hits and how Get Hits helps me build projects like this, pretty quickly, frankly. So I have the PR here, which I'll share with you all, which I'll get merged pretty shortly. So you can take a look at the project and follow along. But this project, was able to complete in just a couple hours. So the first step that I always do, and this is something I had done long before we had AI coding agents, it's just my natural process, is when I'm going to start working with a tool, I need to understand the project or the tool inside out before I ever start writing code. One of the biggest mistakes I've made and I've seen my team makes is we start integrating something before we fully understand it, before we fully understand the limitations. So this is where Get Hits 10x is that process and makes it extremely fast. And what used to take me hours and hours, we can finish in a matter of minutes, because your agent can now explore the exact version of the code base you're working with in real time. So I'm going to start with the package info. And before I do that, I'll just show you the tools that we generally have available. So when you set up your agent to use get hits, you're going to have 4 different main primitives. So the first is code examples. And what this is when you ask your agent to complete a task where it's kind of open-ended, maybe you know what you want to do, but you don't know the library. Maybe you know the library, but you don't know the best practice for implementing it. What Code Examples does is our agent searches a lot of open source code. It finds all of the repos that meet the requirements of what you're trying to do, but then we scan the license, we make sure it's compliant with the license we can use. We check the quality of the code. We check how stable is this project. Is it actively being maintained? Is it stale and have a lot of issues in it? And from that, we give you a single canonical working example with full citation of every single reference of where we pulled the code from. So you have total traceability into where your generations are coming from. The next we have is code navigation. So this is that index I was talking about that we're building of the entirety of open source. So you may be familiar with, if you've been watching your coding agents work against your local code base, they do this grep glob read pattern where they look at the tree of the project. They then will maybe do a regex to search some contents of those files, and then they'll actually read the files to get the context. So we gave your agent the ability to do that against any version of any product in real time without ever having to clone anything. So because we're building the index and maintaining it, it's a stable and deterministic index. So you can just, these are just search requests. You're running against our index without ever having to load anything to your machine and without any context leaving your machine. With the way this integration works, we are only ever reading the queries that your agent sends to us. We're not indexing your code. We're not looking at anything in your code base. The next set of tools is package inspection. So for a package, you can look at dependencies, vulnerabilities, both in the package itself and its dependencies, the changelog, and upgrade changes. And one tool we recently released, which is really cool, is we have a version diff. So say you're updating version of a project you're using, as most of us are pinning our dependencies with all of the supply chain attacks going on right now. We now have a version diff. So you can look at, hey, I want to upgrade to this new version. Tell me everything that's changing about this version versus the one I'm on. And then finally, we also, for all of these, have documentation access. So for any of these tools, you can take a look at the docs. We tend to stick towards the code, which is the source of truth. But there are cases where, there's information in the documentation that we can't find elsewhere. So those are the set of tools I'm going to be giving an overview of. So the first thing I want to do is, let's pretend like I had, never looked into this project before, and this is my first time testing it. So I'm going to tell my agent, use get hits package, which is a skill. You will get that when you run the setup command. And I told it to look up the library, its license, its dependency, the licenses of those dependencies, and lay out what we're working with before we touch the code. So as you can see right here, it's making these search commands to get hit, which is our server. And great, so now we can see it's responding. So we can see the version it's on. It's an MIT license. It's Python bindings for quick description. It shows that it only has one runtime dependency, no transitive dependencies beyond that. We can see, great, and there's no known vulnerabilities. Awesome. So that's a quick check we can do, and you can do this for any library. And say someone sends you a project that you're unfamiliar with. It's not the safest thing to clone random projects anymore, because there are some unsafe projects out there. So this is a great way you can quickly scan the security of something without the code ever hitting your machine. So next, I'm going to ask more about the license. So this next question that I would dig into, I said, based on that license and the dependencies license, explain how we're allowed to use this code, what's permitted, what's restricted, anything to watch out for. So obviously this is MIT license, so it's going to be very straightforward. But this is a command I regularly use because there's a lot of projects out there which aren't MIT. So we're all good on that front. So we already did this. So here we could check for exploits, which the first command already did that for us. So then the next thing I like to dig into is once I've gotten a surface of what does this library look like, it's also a good signal when we see there's only one dependency. If we see the project has, hundreds of dependencies, which then have nested dependencies, that's a little bigger risk we're taking on in terms of stability. So now that we have an overview of the library, we feel good about its security, its version, all that. We need to dig into actually how this project works. So I want to understand, what it's capable of, how it works the way it does, so that I can fully understand how I need to implement it and how I can build something with it. So now I'm going to give it this command, which said using git hits code. Let me just grab that. And git hits code is also a skill here. So that's the skill that tells your agent how to use those code navigation tools I was talking about. So grep, glob, read. So I'm telling it explore Pydantic Monty source to explain how the instance is constructed and run, how code inputs are passed, how the results and std out and std error come back. Navigate the actual source code and base your answer what's in it, citing all the files and lines you used. So that's the other thing is when we do ask it these questions, traditionally with LLMs, when you ask it a question about code, it just gives you an answer and there's no citations, there's no traceability, there's no reason why it gave you that answer. Sometimes there's a web link, but we won't really see the answer there. So here we are making actual searches. You can see the path, we're hitting specific files. So it's doing code read. Here we're doing a grep, so we're searching for a pattern. And it's just gonna run for a little while and explore the project. Once again, giving us the answer from the source of truth, which is the code, not from documentation, which is an abstraction layer and has errors, not from web search, which people write a lot of stuff on the internet. And one of the reasons we're seeing with model degradation is some models have been trained a little too much on Reddit data, for example, which we wouldn't want. Great, so I'm gonna let this keep running. It's exploring. All right, great. I think it's wrapping up its answer. Great. So we can see that the Pydantic Monty instance is a compiled sandbox runner, not just a wrapper around source text. It shows us the shape. And if you notice the source there, we aren't just citing the actual file it's coming from, we're actually citing the lines of code. So very high resolution traceability as to where we're getting the answers from. So it shows the build path is what does the real work. And here it's showing the exact flow of how it works. It converts the code to a rush string, converts inputs into input names, runs type checking, calls Monty. Yes.
Someone has a question. It's in the chat, so I'll read it unless the person wants to unmute themselves and say it. Yeah.
Yeah, go ahead, Christian.
Okay, let's read it. I have one quick question. If OpenCode can read all of the files and change it on my laptop, then can I think it is safe?
Yeah, so a few things there. So the way that this is working, so OpenCode can see the files in the repo you give it access to, just like Claude Code or Codex. And when you run OpenCode, so I've already run OpenCode in this project, but the first time you run OpenCode in a project, you actually have to give it permission to that file system. So first you have tightly controlled access over the file system, but then two, you'll see right here how I'm in plan mode. If you hit tab on your computer, it's gonna switch to build mode. So when it's in plan mode, it's actually not allowed to change anything in your file system. So as I'll show you during the demo, it's a good question. Of course, agents can go rogue and do things you don't want it to. But the way that I build with coding agents is I have a very tight loop where I do planning like we're doing right now, where we're building the context, we're getting the information only in a mode where it can't modify anything. And then we're going to turn that into a plan. And once that plan is meeting our standards, then we let the agent execute against that. So that's kind of how we control for, yes, coding agents can change, things on your file system, but we can control that. And then in terms of where it's getting sent, whichever model you're using. So here I'm using my OpenAI subscription. I have the like the Pro plan or whatever. So the only provider that's actually seen any context of my code base is OpenAI, because that's the subscription I'm using. If you're using Gemini, then Gemini is the provider that's seeing your code. So we're not seeing any of that with GitHits. We're simply, the model provider makes a query to us. So you can see this, GitHits code read. This query is the only thing that's getting sent to GitHits, and it's saying, look at this exact version of Pydantic Monty, given this path and this file, read, these read lines 1 to 180 and return it. So that's the only context we're getting at GitHits from your agent. Awesome, yeah, so we can, yep, go ahead.
Yeah, thank you.
For sure.
Got it.
Yeah, so we can see it, gave a very detailed overview of that answer. We don't need to read through all of it. So, that's about the shape of how it's working. So next, let's look at, so I have a few more here. Let's see, explain. Yeah, so this is a good one. So one of the things I had talked about is the sandbox that Monty creates is running on your machine. And so you can give it permission to file systems on the machine it's running on, and you can give it some access. So because I'm going to be building features around that, I really need to understand how that mechanism is actually working. So here I said, use GitHits. Same thing, the GitHits code skill, explore the source and explain how Monty gives sandbox code access to host functions. So it goes that, based on your answer, give that, cite it, give an overview. So, these are all things that, if it depends on what your team structure is. If you're a smaller team, usually whoever is building the feature, they do the prep work like this. But if you have some engineers on your team, it's pretty common that like your tech lead or your architect is having to do this work up front so that they can have architecture plans and spec files in place. And so I can go through this process where I basically, hammer and question as much as I can about the project with my agent. It gives me the actual sources of truth. And then from that, I can create a really detailed implementation plan so that, there aren't any surprises in the middle of implementation that, oh, this library can't actually do something. These are things we can all suss out ahead of time. Great, so I'll let it keep running. See how I'm doing time. Great. Let's see, and I have a few more questions here, but I think what I can do now is I'll just show you how I would actually, so I already built the project. As we can see, it's built out here, and it's the same thing that's in the pull request I just shared. So I built it out because I want to show you how cool this project is and the kind of controls that you can add programmatically. But before we jump into that, I'll show you how I would transition from, this planning phase to actually starting to build. So I had mentioned earlier that on long-running tasks, we actually end up seeing the agents using less tokens. And that may be a little confusing because this was a lot of text we just outputted here. But there's a few important notes for that. So the first is input tokens and output tokens for every single LLM provider are billed extremely differently. So generally speaking, output tokens, which are tokens are just it's a unit of characters that LLMs generate. So when you give an LLM context, so you say, hey, read all this, those are what they track as input tokens. And then when the LLM generates a response, those are categorized as output tokens. So we're mostly giving it input tokens, so it's just passing it to the models, so those are billed a lot lower. But what you can see here is we're leaving a trail of everything that the agent's going to need to know for how to implement this. So, let's say during implementation, it has a question about Monty start. Well, if it has a question about Monty start, it knows that it can get the exact definition of that. Even if, let's say it's, for some reason during compaction, it was removed from memory. Well, we have a trace to exactly where that definition is. And now that's a single request to get hits. It's not an LLM generation. It's not calling OpenAI and asking it to generate a definition, which is extremely token expensive and it's really slow.
Nathan, it gets even worse because if LLMs need specific pieces of code to load it, what they do is they use lots of tools like grep or whatever to actually find out exactly what it is. No, it's all, once you have this, then they don't have to look for it.
Exactly. Yeah, and that's exactly the point. So I load up this context, and then the way that I build with agents is I have a very tight loop of I do plan, review, implement, review. So the first step is I say to make a plan. So let's say I already have some code written in this code base. So I'll just say we're building a new feature. I want to build a Great. So now I said we're going to build a new feature. I want to build a mechanism so that if a session crashes, we can resume it from any machine. Given the context above, make a detailed plan. So, I generally have a more tightly scoped and detailed prompt, but just I want to show this general example of how I built the project. So once we get the context, I then create a plan. And while that's running, I'll just show you my next step, which is always the same. We publish these skills, which I will link to because they're free and available for everyone. And we'll keep adding some more skills here. So these are the skills that are specific to get hits are in our actual CLI, which this is our CLI. It's completely open source. So y'all can take a look at that. Feel free to copy how we did the setup command. So here, these are just general skills that we find useful. So we have a code reviewer skill, which tells you how to review the code base. And what's cool about how we structure them is they respect the rules of your code base. So if you already have your architecture and agents.md and all of your rules for how the agents are supposed to work against your code base, these give the agent instructions of how to do a high quality and thorough code review, plan review, test review, while respecting your guidelines. So these are the skills I'm going to be using. So I let the agent assemble all of the information. It usually generates a very inconsistent structure, doesn't follow any rules. So I simply just say, use plan-reviewer to review and update the plan as needed. Be sure to include a to-do checklist in the final plan. So this is that skill I just showed you. So its objective is It's going to review the plan, update the plan. And the reason I said to do checklist is a lot of tools now have actually started to build trackers into them. So Codex has it. So if you create a plan and you just use the markdown format for checkboxes, that's actually a tool that the coding agent will register so that it can check it off and know that it's completed a step. Great. So here we can see this is the plan that the agent would execute against. So we say, current lab implementation. It shows lines of code. So very, very context-rich plan. So basically, once the plan's reviewed, I then simply just would switch to build mode, and I would tell the agent complete the plan. And then once the agent completes building, the next thing I do, I'm not going to run it now because the code base is already written. But the next thing I would do, just like I did in the previous command, I said, use the plan reviewer to review the plan. Now that that plan has been converted into actual code, I then simply tell the agent, all right, now use the code review skill to review it. And what I always do is I'll do a hybrid of looking at what the agent gave back. I will actually go look in the code, and then I'm always looking at the changes myself. So what's nice about Superset is you can also just open any of these projects in your IDE. So here I can just open them up in Cursor, which is a little easier to view some stuff. It's pretty much just VS Code. And I'll check the actual diffs. And so this is a way that I can work really closely with the agent, but also make sure that, we're not letting anything slip through. So then, yeah, that's pretty much the loop I do. And I try to do it on pretty tightly scoped tasks. So when I was building this, I split it into 3 different phases. First, just, phase 1 is just get the sandbox to work. I just want a program where I can open a chat interface and give it some basic commands. And one other really cool thing I'll show about how I structured this project and how Monty works in general. So Monty follows a lot of different configurations. So I'll just show a quick overview of some of the cool tools. So I called the project SafeBox. We have our CLI, which is just our entry point. But then I will show the actual gates. So we have we define, whether we allow or deny something. And then here we can, with classes and objects using the, structures that we're so familiar with in programming, we can define the rules of access. So we can have file read rules. We can have file write rules. We can have list file rules. We can have get environment variable rules. And what's great is rather than just trusting the LLM, which these are probabilistic models, which can regularly do hallucinate. So rather than trusting them to say, oh, follow this rule of these are the files you can and cannot access, we define those rules programmatically. And so these are actual Python functions which are defining the permission boundaries. And so then for the network calls, so for this part of this demo, I gave the agent access to call get hits. And so here we define which functions we're actually allowing the agent to call. And then we're not just leaving it at, this is just the permission boundary and then the LLM can, hallucinate any call it wants. Here we define the actual functions. So we define the get hit search. The only thing that the agent's allowed to pass in is the query and the target and the source. So what's cool about Monty is it lets you use LLMs for what they're good at, which is going from unstructured to structured. So in this case, a prompt to passing parameters to a function, but then we're actually using Python for the actual execution.
You do have a question, so I'll intervene. So yeah. How is the prompt injection risk handled here?
That's a great question. So prompt injection is a very wide So I guess we could just go through a few examples. So let's say that you tried to inject a prompt. So the LLM itself, it's only going to have access to some system prompts. So if we go to agent here, there's a pretty basic system prompt for the agent. But then let's say that one of those malicious prompts actually got passed to get hits. Well, the only thing the agent would be able to do is pass that prompt as a query parameter, which this is a search function. So it would pretty much, it wouldn't get anything. So fundamentally, like the way that this structure is working of allowing the LLM to call a function, but the LLM is never actually executing anything. It's only ever these functions you define. So there wouldn't really be an opportunity of leaking because the functions would probably just throw an error. So this is what's great. Like on a more traditional agent, they're using the LLM to control everything. And that's where you get these risks of prompt injection or getting the agents to leak something, because via prompting, people can trick it to do something. Whereas in this case, all of the actions that the agent's actually allowed to do are programmatically defined. So the way that you can think about it is this framework is designed from the principle of least privilege. So it starts with 0 privilege and it's only allowed to do what you let it. And the way that we define that is, so I built a few different versions of this so I can show how they behave, just to show you the overview. But you can just simply define the permissions with a config file. So for the sake of this demo, I wanted to keep this entirely local. So I'm using Ollama as for running the LLM. And then the actual model I'm using is Gemma 4 EB, which is from Google. I would highly recommend the Gemma 4 models to folks for testing out. We do a lot of experiments with open source models, done experiments with Quen, Kimi, handful of others. And I have to say, we're very impressed at how good the Gemma 4 models are at agentic tasks. So they're very good at tool calling. They're good at making structured requests. As you're going to see in this demo, it's actually writing code, which is pretty impressive because this is a 4 billion parameter model running entirely locally on my M3 MacBook. So yeah, I'd highly recommend checking out the Gemma 4 class of models. And if you actually have a GPU, their 26 billion parameter model is pretty interesting and cool for coding. So that's the LLM side for the agent. So we define how the agent runs. Then these are the actual permissions. So once again, former approach where people write prompts and markdown files where they basically write a million instructions in all of the edge cases, hoping the agent follows it, whereas it regularly doesn't. Here, like I said, we start from a place of least privilege, so it has no access, and we grant it access. So here, I'm saying, okay, you can read from this file, which is this folder, which is right here in the project, and you can write to that folder. You don't have any access to environment variables. You do not have any network access. You cannot use get hits. So yeah, it's really nice if you can basically just create configs of defining the rules of what the agent can and cannot do. So once again, not trusting an LLM, but just using code. So here I will run the first version of the tool. Actually, let me just. All right. Just gotta switch to raw. It's copying a little weird. All right. Great. So here we can see that this is the write scratch. So I basically gave the agent access to write there. And so I'm going to try to break it first just to show you what happens. So here is an area where I see LLMs do a lot of not great things, which is they'll try to reach beyond the boundary they're allowed. So here we only gave it access to the scratch folder right there. But I'm going to tell the agent, create me a readme.markdown file in the root. Oops. And the project and the. So here I'm asking it to take an action outside of its permission boundary. So we can see that the agent returned the request. It's asking the model. So now this is OLLAMA right now. So the Gemma 4B model is trying to write Monty code. And so that's the other thing is the model generations are all scoped to they're only executing within Monty. So here, let's see. All right, it failed. I put a retry mechanism, so I don't know if it's catching blocking permissions versus a pure failure. But yeah, so basically it's not going to allow it to right outside the permission boundary. So I'll let this finish. So you know what, I'll just kill it because it's going to keep asking. But yeah, so basically, as we can see there, we asked it to work outside its permission boundary. It did not allow it to. So now I'm going to say, what the heck? Got some key binding stuff going on. All right, great. So now I'm going to tell it create me a README file in Scratch, the folder we gave it permission to, with a short hello world description demo. So now I'm asking it an actual command that it's permitted to do. Great. So we can see it returned the results. So it created a folder in README. So let's take a look under Scratch. Great. Yeah, so it just, executed the command like it was allowed to. So I'm going to kill that and show you the next level of demo. First, I'm just going to remove that. So now phase 2, what we introduced in here is we started to give the agent access to network. So here, I'm going to give it no permissions. So this SafeBox 2, it has the ability to make network calls, but because it respects the configuration by which you give it, for this config here, I defined, it's deny all. So it's going to block everything. So here, let's give it a command, which it technically can do, but we're not permitting it to do. And we're going to see it fail. And then here, and the way it's structured, so the way I added this config command to the CLI. So basically, you can just point it at whichever config file you want. So this is a way that I could very easily run the same CLI with a lot of different commands to show you how well these permission boundaries work without having a bunch of different projects. So great. It said get hits helper disabled. So it was not allowed to. So now I'm going to kill that, and I'm going to restart the agent with the config that gives it access to get hits. And so now I'm going to tell it, use get hits to search for how Pydantic Monty runs code, target that, summarize what you find. And oh, go ahead.
There is no, go ahead, it's just a bit here. You can continue, sorry. I was unmuted.
Great. Yeah, so we can see that it made the actual request. It returned the response. So it worked as expected. Some weird key binding thing going on. So now I'm going to show with that same permission. So here, we gave it access, as we can see, to get hits. This is an area where it would be easy for an LLM to leak. So let's say that it was given general network access. If you were trying to use a skill file or a prompt to tell the agent, hey, you're only allowed to search get hits, it, wouldn't catch it. It would let some stuff through. But here I'm going to tell it, oh, I know that this agent has networking tools. It just made a get hits call, no problem. Search, example.com. But, when we go to the actual config, if we go to the phase 2 get hits, we can see, yeah, we do allow network, but get hits is the only network call that we actually allow. And so if we take a look, it can say,
How to distinguish get hits from other network calls? You just said get hits here, but like.
Yes, great question. So if we go to get hits helper, so this was here where we defined these the exact queries they were allowed to make. So the only network calls that this is allowed to execute is this function, get hit search, which makes a search request to our API, and then the get hits example. So that's how tightly scoped we can gate it, is we not only can block like other network calls, but we can define the exact calls it's allowed to make. And then, yeah, so we can, ask it to do some multi-step stuff where it can run, do a search and run code. So next, I'm going to show you, now let's look at the actual snapshot and resume. So this is another really cool piece of functionality that this tool provides. And I'll just, before I run the example, I'll give a few real world examples. So something that's interesting about scaling agentic applications is user sessions are extremely, extremely variable, and unlike any other software we've built historically. So if we were building a traditional CRUD app, every single workflow and every single action that a user takes is extremely, extremely predictable. We know the steps, the API calls they make, the order in which they make them. We even have tight limits on how many of those calls can be made, or if the call can even be made again. So user workflows and activity on traditional apps are pretty predictable, and we can scale somewhat linearly. However, where this changes with agents is these are open-ended interfaces. So a good example is with our code example endpoint, that's an actual agent that's doing that task. We have some cases where a user's query takes up, 10 to 20, 30,000 tokens of the agent going back and forth and evaluating before it completes its task. But we've also had some users whose queries actually end up taking 1 to 2 million tokens to complete. And so this is something that's pretty interesting. We're talking about the same exact endpoint here, one single endpoint, and the variability in compute that it's using is literally magnitudes of a million plus. And so this can make scaling really hard if we have a serverless deployment and we have many agents running. We could have a user that has a session where they just keep going and keep going and keep going, and it takes up space on that server, so that we need to start routing these other users that sessions are also being handled on that server to a different server, because we don't know how long they're going to keep going. And so what's really cool about that is with this snapshot functionality, you can snapshot all of the interactions they've had, everything that they've executed, the full context. You can transport that snapshot. So then we could very easily make sure that the user experience, they can just have their session keep running, whereas I'm sure all of us on this call have experienced ChatGPT or Claude or Anthropic run into issues where it fails, it disconnects from us, it won't want to restart. Those are the scaling issues we're experiencing. So this is a really, cool way that you can, build your products to scale in really incredible ways that would not be very straightforward before. So I ran it with this config now with snapshot. So I'll show what that looks like. Awesome. So here we just have read and write access. We have network turned off, so pretty minimal permissions. And let's see. So here I'm going to say create Scratch phase 3 demo.markdown. So create this file, but pause for approval before writing. So great. It tried to make a call to the agent, but it needed approval. So what I'm going to do is I'm just going to kill the session. And generally, anyone who's used an agent or chat interface or anything, you kill that and it's usually gone. But here I'm going to resume it, and I'm going to approve it to take the action. So great. I just started a completely new session, a completely new process from scratch. And it, as we can see, ran the command, it resumed it, it loaded the snapshot right there, and it picked up exactly where it left off, and it completed the task. So I'm sure everyone on this call has had an experience where you send a prompt, and maybe it was a really long prompt that you worked on a lot, and the session freezes and you lose it. Here, we were able to just send the agent a prompt, kill it without it completing, and then pick it up and have that same prompt, which never went through, get executed, and then the action was taken where it actually created the file. Yeah, so that's pretty much the tool. So those are like the main pieces of functionality that I built out. So, using Monty to control the file system, using it to control the network, and using it to snapshot and preserve sessions so that you can pick up where you left off. And also in the project, I put these build plans in there. So you can see these are some of the plans that my agent was working against as I was building. I just left them as traces in there so you can kind of see how we built out. But, projects like this, which, if I was building this a couple years ago, this would have taken me quite some time to get stood up. But I did that process I showed you where I deep dove into Monty. Also, this is the first time I've built anything with Monty. I saw it demoed a few weeks ago from the Pydantic folks and have been wanting to test it out. So I was like, oh, this is the perfect opportunity. So I genuinely went through this process from scratch. If I didn't know anything about it other than the demo, I dug into it. From that, I quickly realized, oh, I can very easily build a demo where I have a chat interface and show these different levels of control. And then I was able to build this whole project in a matter of a couple hours. And the most notable thing of when we build with get hits is I loop and iterate a lot with the agent, but one of the best pieces that integrating get hits into your agent gives you is I'm never having to deal with the agent hallucinating or just making up code or writing code that doesn't work. Pretty much all of my feedback that I'm giving the agent has to do with actual features and functionality. So here is my actual session where I built it. And if I'll go to some prompts. Let me see. Oh, this is another cool trick, which everyone is really good for testing. So a little bit of a tangent, but worth noting. So if you go to the build plans, there's going to be a file in there called full agent test plan. And unit tests are great. They are good for coverage, but at the end of the day, actually running the tool in the way that's going to be consumed is the best way to test it. And so because agents have the ability to control a terminal and run CLIs, I built this project as a CLI. Here, it has a checklist of every single command to run. So, I give it the actual command, it runs the agent, it runs the prompt, and then it verifies the output. So here it's a really good trick of avoiding drift. So a lot of times agents will lose focus as to what they're working on. Sometimes you'll put it on a new task to fix and it'll break some other stuff. So by creating a document like that, where you give it full integration test for the entirety of the functionality you expect, that is a key component of the plan. So at the end of every single plan, it cannot say it's done until it's respected the behavior that you expect of it. So these are just a lot of ways that we, try to get the agents to behave. But if I can show some examples in here, pretty much all of my feedback has to do around functionality. So I'm iterating with the agent on how it should be working versus telling it, oh, you just gave me hallucinated code and you keep telling me it's working, but it's not working. But yeah, that's what GitHits is. This is the Monty project I built with it. Yeah, I'm gonna merge it. This is just a demo. Feel free to take what you like from it. Yeah, love if anyone has questions about Monty or GitHits or just how I code with AI.
So allow me to start a little bit of a discussion here, because you didn't mention all the things that GitHits is good at. So you went through the licenses a little bit, but it's important for people to understand that this licensing problem is actually a security problem, because anyone who starts a project, especially in a big company, if they get stuck with the wrong library, it will impact whatever they're doing, and they might, and they may basically the company will lose the project just because the wrong licenses went in, like copyleft licenses that you appeared. So basically, GitHits is a security tool as well, and you'll probably talk more about security in a second. But one more thing that I use GitHits for: before you actually start a project, before you even start planning it, you want to know who your competitors are. Like, are you inventing the wheel, stuff like that? So I actually started developing something not long ago, and at the same time, they give me the access to their beta, and I said, okay, let's explore all the projects that are similar to mine. And GitHits found it, and with GitHits, I was able to explore and find, oh, they don't have this. Oh, I plan to do that. Basically, it's marketing material for yourself using the entire internet. Yes, you can do it with an agent, but GitHits is a little bit more accurate with accessing the licenses and some other things. So I would recommend it only for that. So before you start a project, go to GitHits, ask questions. They are not paying me, guys. I actually tested the tool myself, and it helped me with my own product. So, Nathan, tell us more about security, unless someone else has questions.
Yeah, love to talk about license. So, yeah, like Jacob said, we have really strict license filtering. So if you go to our web app, so we also have a web app. Generally, people work with their agents, but you can do your searches from here. And this is only the examples at the moment. So going back to these different primitives, right now in the web app, we just have code examples, but we're working on getting the other tools into the web app because that's some feedback we've gotten from folks. So you can also see the searches you make from the web. You can also, all of the calls that your agent's making, and right now it's examples, but like I said, we're working to get all of the session context in here. You'll be able to see all of the calls that your agent's making in the web app. So you can have total traceability into what's being read. So here we can actually see the sources where it came from. We can see the permalinks, actual code. And here we have the license. And I'm going to go to my settings and show you, there's a lot of different license, right? So here you can do license filtering. So you can do strict, you can do YOLO, which we do not do. Personally, we use strict mode. And what that does is it blocks copyleft license, repositories with no license, and unknown license. So at your user level, you can control which, how you want to search, but also in the tools themselves, you can specify which mode you want, You can also specify which license you want to filter out. Maybe you have some internal org requirements where you're not allowed to use particular license. You can put those in the search request to actually filter them. And then let's take a look at the security stuff. So you know what? Let's go to, you can just use Codex and use get hits to scan. All right, so let's look at the TANstack project for vulnerabilities. And I said, let me know about previous ones. Let's see if it checks the audit. So as you all might have seen a couple weeks ago, there was a pretty severe supply chain attack that hit TANstack and spread across quite a bit of the internet. And what was very cool was the moment that that exploit was published, the first thing I did was hopped onto my agent and I said, tell me about, and I looked up the exact version of the exploit. So I said, tell me about this version of TANstack. And the get hits agent said, I'm sorry, I can't tell you anything about that. That's a, that package has some vulnerabilities like in it. We're not even going to return it. So that's another cool factor of if you're trusting web search, there's very good likelihood that an agent can grab an infected library without knowing it and just clone it to your machine without you knowing anything, which is pretty dangerous. Whereas here, if you're using get hits as the proxy to inspect packages, that's never even a risk of it touching your machine because if it's an infected library, we won't even return any context from it. We'll tell you it's dangerous, but the search functionality against it will not work because we won't let that hit your machine. Great, so let's see if it gives the report on the TANstack package. But yeah, so and also, yes, and another great thing you can do is with these tools, there's a lot of parameters. So I'll just open it up. So the npx command that you use to sign up, we serve our product as a CLI via npm. It's just called the get hits package. And it's a CLI and MCP hybrid. So when you connect it to your agents are actually running an MCP server over STDIO. But we intentionally made it a hybrid so that you still have access to the CLI. So here you can see all the CLI commands. And then because we built this for agents, there's a lot of different commands. So if I do get hits, package -- help, you can then see, so yeah, you can see the different options. So for the package command, you can get info, vulnerabilities, dependencies, changelog. But let's see what get hits said. So I looked at get hits against the changes. Previous TANstack issues it found. So there we go. And then get hits examples of affected old versions. We can see the actual vulnerabilities. So yeah, what's great is, if even, let's say that you came into a project and there was potentially a dangerous version in there, this is something we could catch really quickly because we're scanning for these vulnerabilities and our index holds it. So it's not just, it's not just we're checking on the fly, but we actually store that and secure it. So it's a very quick lookup for us to know if something's dangerous or not. But yeah, those are the two. Yeah, that's how we handle license and security vulnerabilities.
Yeah. If someone else has a question, please jump in and ask. I will continue with one more question. What about privacy? Like if I use get hits, then?
Yes. So you can go to our website and check out our legal. So here we have terms of service, privacy policy, cookie policy, data processing agreement, and subprocessor list. And the reason there's a few more documents than you'd expect, we are GDPR compliant. My co-founders are in Finland, so part of our company is Finnish. We use GitHub for authentication. The only things that we use GitHub for are your public metadata. So just any public projects you've seen, we do not see anything about your private repos. We do not get access to your private repos. And then the second thing is we still occasionally use GitHub search, like you could see here, where we actually show you the sources. We link to GitHub. So in that case, you just use your own GitHub token for search. So those are the only things we're using from GitHub. Like I said, we do not index anything from your local code base. We do not access your private code bases. Your agent does not give us context about your code base. The only thing that your agent is allowed to do is run these commands. So it can, it can search, it can do code navigation, it can do package, it can do documentations, but it's not getting anything about what you're working on. And then in terms of training, we do not train on any data. We do have a clause in our documents that down the line we may do that at some point. However, we structured it as an opt-in. So if we do decide to start training at some point, that is something that you will have to opt into. We will not forcefully opt people into that. But yeah, we have all of our docs in terms of service published on the site. So we want to err on the side of privacy, only getting access to what we need. And it also makes it a lot easier for us because we want to help as many developers as we can. We want to get into as many developer organizations as we can. So by erring on the side of using as little information as possible, it just makes it a lot easier for us as well to get people using our tool.
Meaning if I develop something, my own secret project that I don't want anyone to share, know what I'm doing, then would you say it's safe to use GitHits?
Oh, absolutely. Yeah. Oh, we do. Yeah. I mean, we build our indexes. So that index we're working on is extremely proprietary because no one else is doing it at the moment. A couple of folks are catching on, and we very heavily build our own product with GitHits.
Yeah, but the minute you publish it on GitHub, then anyone who has GitHits can see, correct? Or only if it's private or if it's public, or how does it work?
Only if it's public. We have no ability to access private repos. So the GitHits index is purely open source code, no proprietary code.
Okay. Anyone else has questions, guys? Come on.
I just want to say that this is an awesome product. I loved every minute of this talk, and I'm looking forward to going back through the tape to learn a lot more.
Thank you. Really appreciate that.
Okay. Anyone else?
But I see you automated your own process and decided, hey, everybody else can benefit from this, and you're spot on. This is awesome.
Thank you. Really appreciate that. Yeah, we're very happy to, and a quick note, like if anyone has teams that you'd want us to do this for, we're helping teams manually onboard and showing them how we build with AI, just because we've been seeing a lot of teams are having a hard time adjusting. Either their costs are getting out of control, they're having too many bugs. So we're very happy to share our learnings and make them as public as possible of how to safely build with AI, because at the end of the day, people using these tools safely and in efficient manners is how we can, make sure our product provides value to them. Whereas if, people are having a lot of issues from the start, there's not going to be a reason to use GitHits. So we're very happy to help teams upskill and learn how to build agentically.
So how do they contact you if they want to use something, or like what's the mechanism if they want to invite you, if there's a team somewhere and someone watches this video?
Absolutely. So you can connect with me on my LinkedIn. I'll drop this in the chat right here. So I'm really responsive on LinkedIn. You can also...
These are the people that see. Can you just share the screen on your LinkedIn? It's
yes.
okay.
Yep.
then share it so people can know who to contact, and like we'll see the link if they're not on the video.
Absolutely, yeah. So I'm always on LinkedIn, so send me an invite. Feel free to drop a message in there. Yeah.
Share your screen with the LinkedIn. So
Oh yeah. Let me do that real fast.
So the video will capture it in case someone watches. Yeah.
Yep. So we're our colors are very easy. We're the bright pink. So easy to spot the profile picture. Nathan Burg and then pink profile.
Okay. So in that case, unless there's more questions, first of all, let's thank you. So make some noise, clap, whatever. I personally loved using GitHits. It helped me with my own projects, but I'm biased.
Yeah, I can see that's really impressive. I'm excited.
Yeah. Anyone has any more questions, or we can adjourn the recorded parts? Questions going once, questions going twice, questions going 3 times. So Nathan, thank you very much. Don't go away. We're just stopping the recording.